signal. So what do you mean by step signal? So if you can see your step signal is looking like this. It is just looking like a step. It's just looking like a step. So this is called step signal. So the step signal, if I want to draw its graph, time versus amplitude graph, let this is your time axis. Let this is your time axis. This is your time axis. T equal to G. This is the time axis. And here let I'll tell that T equal to 0. Okay. So you can see here before T equal to 0, that means when T equal to minus infinity to 0. So this portion is called T is less than 0. And the portion when T is starting from 0 to infinity plus infinity, that portion is called T is greater than 0. Okay. So from minus infinity to 0, the amplitude is 0, just like a switch off condition. Just like a switch off condition. At T equal to 0, I am switching it on. So the circuit will get a voltage or current having some amplitude, let A. Okay. So at T equal to 0 up to infinity, that means when T is greater than equal to 0, the circuit will get a value of voltage or current having amplitude A. Okay. The base Rayal, just mute your mic. Just hold for it. You're not muting your mic. So here the step signal we representing as A of ut. Okay. So A of ut. So the value A of ut equal to A when t is greater than equal to 0, and the value will be 0 when t is less than 0. That means it acts as a switch. Before t equal to 0, the value will be 0. You can see here the value will be 0. And after t greater than 0, the value will be here treated as A. Okay. So the A is nothing but the amplitude. Now, if this A value will be 1, that is called unity step signal. Okay, this is called unity step signal. Okay, if A value is 1. Now, I have already in the last class, in the classes, I have already draw series RC circuit. If you remember, this is the voltage source Vs. There is a switch here. The switch is going to close at t equal to 0. This is R. This is your C. So this is your R. This is your C. So this circuit means at t equal to 0, the circuit is going to be closed. T equal to 0, the circuit is going to be closed. Before that it is open, and after that is also closed. So this circuit we can replace, or I can redraw this same circuit in terms of a step signal. So I will write down like this. So instead of this switch, I will remove the switch. So I'll put a plus minus sign for the voltage. I'll write down Vs into U of t. Vs of U of t. I'll just place R and C. This is R, this is C. So both the circuits are same. So instead of putting the switch, which work is to close the circuit at t equal to 0, the same thing we can do here by writing this step signal Vs of ut. So that means this Vs of ut will provide a voltage Vs when t is greater than equal to 0, and 0 when t is less than 0. This is nothing but the function of switch. This is the step signal. Okay. So when I am providing a step signal and I am getting some output, that output is called step response. I already told the response is called output and input is called as excitation. So I can say here the signal or the output due to the step signal is called step response, or the output due to the step signal. So now uh, if in the circuit, if any of the question you can see it is written Vs of ut, then you think that this is a switch which is going to be closed at t equal to 0. So now another question is that if I want to switch the circuit at t equal to 1 second, or if I want to switch the circuit at t equal to 5 seconds, that means suppose this is your time axis, this is t equal to 0, and I don't want to switch on the circuit at t equal to 5. Instead of, I want to switch on the circuit at t equal to 5. That means at t equal to greater than 5, the circuit is having a value of A. And before that, that is 4, 3, 2, 1, 0, -1, -2, the value will be 0. So type of this type of signal also you can represent in terms of step signal. So I can represent here, this is A into U of t minus 5. A into U of t minus 5. That means if t minus 5 is greater than equal to 0, I can write down t equal to 5. So at t equal to 5, I am putting a step signal. Before that, the amplitude is 0. And after that, the amplitude will be A. Similarly, I can switch on the circuit at t equal to -1, t equal to -3, which is practically impossible. Okay. So this is all about your step signal. Now we start with the step response of a series RC circuit. So step response of a RC circuit. Okay. So if you have if your class note with you, you can see here we have a battery here Vs, and we have a R series circuit R here, and there is a capacitor C, and the circuit is going to be switch at t equal to 0. Okay, the circuit is going to be closed at t equal to 0. If you remember there, the voltage across capacitor, I already told, will not change instantaneously. That means Vc 0 minus Vc 0 plus is nothing but 0 voltage. This is your RC circuit with source. Similarly, we did the RC circuit without source or source free RC circuit. Okay. So here we did like this. We find out what is VCT. If you remember, VCT is nothing but VC into, so Vs into 1 minus e to the power minus t by tau. This is the for RC circuit with the source. Similarly, we did for the RC circuit without source. If you remember, so this is a Vs, this is A, this is B, R, C here. I told that at t equal to 0, the switch is started from A to B. The switch is moved from position A to B, and I got there Vc 0 minus Vc 0 plus equal to Vs. That means the capacitor is charged up to the voltage V, and I got the capacitor voltage is nothing but Vc equal to Vs into e to the power minus t by tau, where tau equal to Rc, that is called time constant. Up to this we know. Okay. So in both, if you remember here, I have taken here the initial voltage. The initial voltage across the capacitor is 0. The initial voltage across capacitor is 0. And if you take this particular circuit with source free, so when it is connected to when it is connected to the node A, the capacitor is fully charged. So I got Vc 0 minus equal to Vs, and at t equal to 0, it moved to position B, and at that time also Vc 0 plus equal to Vs, and Vc infinity I got 0 voltage. That already we know. Now another type of circuit I want to design here. This is your battery Vs, this is your R, this is switch R, the capacitor C here. Let the voltage across capacitor is Vc. There is a switch here. which is going to be closed at t equal to 0. But there is a assumption that the initially the voltage, some voltage is stored at the capacitor initially. So basically in the series RC circuit, we are assuming that previous initial voltage is 0, but now in this case, I'll assume that VC 0 minus and VC 0 plus, there is initial voltage is V0. That means when we have taken the circuit, previously the capacitor has some initial voltage that is called V0. Okay, initial voltage is V0. Previously some voltage is there V0. Now I have connected the circuit with a source which is voltage Vs, and will assume that here Vs is greater than V0. Vs is greater than V0. Okay. So now you just do one thing. So if you remember the time axis, if I redraw this time axis here, let t equal to 0. This is t equal to 0 plus. This is t equal to 0 minus. Okay, t equal to 0 minus. And this is minus infinity. This is plus infinity. Okay. Now, before the circuit is switched on, that means t is less than 0. T is less than 0. The circuit is open and there is initial voltage here. So the initial voltage here I can find out here Vc 0 minus equal to V0 volt. Then at t equal to 0 I switch on. At t equal to 0 switch on and the circuit is closed. Just after switching I want to find out what is the voltage. Vc 0 plus is also same. Why? Because voltage across capacitor does not change instantaneously. Okay. So now I close the circuit. Now I want to find out what is voltage at t equal to infinity. Okay. What is the voltage at t equal to infinity? You know, when t equal to infinity, the circuit achieves steady state or capacitor behaves as a open circuit. The capacitor behaves as a open circuit here. Okay. So no current will flow. Let me redraw this one. Let me redraw. This is the circuit. This is your Vs. This is your R. The capacitor achieves steady state, that is open here. This is the Vc. So no current will flow. The voltage across capacitor is nothing but the source voltage. So Vc is nothing but the Vs. That means I can write down here Vc at infinity is nothing but the source voltage. So here when before switch on I have a voltage V0. I have a voltage at t equal to 0. Let our voltage is V0 and t equal to infinity. The capacitor is charged up to the source voltage V at t equal to infinity. Capacitor is charged up to Vs. Let this is your Vs. Okay. Now I already told that Vs is greater than V0. That means the capacitor voltage will do like this, will behave like this. It is increasing exponentially. So now I want to find out what is this equation of this capacitor voltage here. Okay. So the equation we need to remember here VCT equal to, we can write down the equation here. Write down VCT equal to Vs plus V0 minus Vs into e to the power minus t by tau. This is the total response. This is called total response. This is called total response. That includes your transient response and steady state response. It includes your transient response and steady state response. Okay. So if I'll put the in this equation what is the value of t. I'll put here, you can see here, if I'll put Vc0. So you can see here Vc0 is nothing but V0. If I'll put t equal to infinity, I'll get Vc0 nothing but Vs. Okay. So this value, this Vct is nothing but when t is greater than 0. Okay, this is the total response. You remember, you will get a 10-mark question from this to find out the total response. This is Vs plus V0 minus Vs into e to the minus t by tau, or you can write down a formula for this. Write down here. So all of you please write down in your class note. Vct equal to V at infinity plus V at 0, Vc at infinity, Vc at 0 minus Vc at infinity into e to the power minus t by tau. This is RC circuit, tau equal to RC. You can write down this equation. You can see both the equations are same. So Vc at infinity is nothing but Vs, Vc0 is nothing but V0. Okay. So just remember, if you they will ask total response to find out total response, or if you can see in the circuit there is two sources are there, then you need to find out the total response. The total response, the voltage across capacitor is voltage across capacitor to infinity. Then the initial voltage, this is the initial voltage. This is the initial voltage. What? Okay, this is the initial voltage. Okay. So just all of you please write down in your class note. I will solve some numerical from this. Please write it down in your class note. Okay. Now we'll have a circuit here, RC circuit. So draw the circuit first. All of you please write down in your class note. So you'll get definitely 10-mark questions from this total response. Because this is 24 volt, 3 kilo ohm, this is 5 kilo ohm, this is 4 kilo ohm. Okay, so please write down. So the circuit will be given and there is a switch like this. Okay, the switch is 1 minute. 1 minute, just hold for a minute. The circuit is like this. No, no, no. Okay, this is your B. The slight correction here. Okay, so the circuit means the switch is in position A for a long time. You can write down the switch is in position the switch is in position A for a long time. Long time at t equal to 0, the switch moves to position B. Moves to B. So they're asking find out VCT. Finding VCT for t is greater than 0 and also calculate VCT at t equal to 1 and 4 seconds. Just write down the question. You can unmute and you can reply whether completed the question or not. Am I audible or not? Question completed. Okay. So now you can see in the circuit, they are saying that the switch is in position A for a long time. At t equal to 0, the switch is moved to position B. Okay. So first we will write down the diagram of when switch is in position A for a long time. So see here, this is case 1, it's called case 1. So switch is in position A for a long time. So I'll draw, this is 24 volt. This is 3 kilo ohm. This is 5 kilo ohm. And the switch is connected. This is the position A and the capacitor is connected like this. 0.5 millifarad. Okay. They are saying that the switch is in position A for a long time. So long time means what? Long time means if you see the time axis, if you remember the time axis here, so the switch is position A is long time here. So generally, after 5 time constant, it reaches steady state. So let the switch is in position A before 1 day or 2 hours or 2 day. Now when you see that the capacitor achieves steady state. So the capacitor achieves steady state means capacitor behaves as a open circuit. The capacitor behaves as a open circuit. Okay, so the capacitor is open circuit. So I want to find out what is voltage across capacitor. Okay. So voltage across capacitor is nothing but the voltage across A and B. So this is A. So I can say that this is node is also A. This is B. Hence this is also B. Now VAB is nothing but the current flowing through the 5 kilo ohm resistor into 5 kilo ohm. So now this is open, no current will flow here, no current will flow here. Now I can see that what is the amount of current is flowing. So the current is nothing but 24 divided by 5 plus 3, that is 3 ampere of current will flow. Okay, so when 3 ampere of current will flow in this direction, current will enter here plus, leaving here minus, enter here plus, leaving here minus. So I can find out VAB, nothing but 5 into 3, 15 volt. So I'll get here 15 volt. So I can write down here VC, voltage across capacitor just before switching, and voltage across capacitor just after switching also 15 volt, because voltage across capacitor does not change instantaneously. This is called initial voltage. Initial voltage. Okay, I got initial voltage is 15 volt. Now at t equal to 0, the switch is moved to position B. So I'll write down the case 2. So I'll redraw this diagram again. This is capacitor 0.5 Faraday, sorry, millifarad, 0.5 millifarad. This is 4 kilo ohm connected to another source of plus 30 volt. Okay. See here, I got the initial voltage. Now this is the switch moved to position B. Now I want to find out what is the voltage at t equal to infinity. So at t equal to 0 minus t equal to 0 plus, I got the voltage 15 volt here. Now at t equal to 0, it connected to position B, and at t equal to infinity, I want to find out what is the voltage. Okay. So when t equal to infinity, again this capacitor also behaves as a open circuit. The capacitor behaves as a open circuit. So it behaves as a open circuit. Let okay. I want to find out what is V. This is your C. This is your D. So you can see here at t equal to infinity, the capacitor behaves as a open circuit. No current will flow. So voltage across capacitor at infinity, nothing but the source voltage here, 30 volt. 30 volt. Okay. So that I got here, voltage across capacitor at infinity. Now what left? Now you need to find out time constant. Time constant is nothing but RC. At when t is greater than 0. So now the thing is that we need to put this capacitor here. Capacitor value is 0.5 millifarad. So time constant I can find out 4 kilo means 4 into 10 to the power 3. 0.5 into millifarad means 10 to the power minus 3. So I'll get time constant is 2. I got time constant is 2. I got time constant equal to 2 here. Now I'll just put in the formula VCT equal to voltage across capacitor at infinity plus voltage across capacitor at initial value of the voltage, then voltage across capacitor at infinity to the power minus t by tau. Okay. Now I can put all the values. I have all the values, so I'll get this is 30 volt. Then voltage, initial voltage you can see here. This is 15 volt minus 30 into to the power minus t by tau. Tau equal to 2 I got. So you can write down 30 minus 15 into e to the power minus 0.5t. This is your VCT. This is voltage across capacitor when t is greater than 0. Voltage across capacitor when t is greater than 0. Okay. So now the second question they asked, what is voltage across capacitor when t equal to 1 second? So just I'll put 0.5 into, instead of T, I'll just put 1 here. So I'll get the value is 20.9 volt. Similarly, VC at 4 second, I can find out 30 minus 15 into e to the power minus 0.5 into 4. So I'll get here 27.97 volt. Okay. So this is one of the example already given in the book. You can check there. Okay. So always remember this formula. So this formula will helpful always. So this is the formula. This is the formula you need to remember. Okay. Next question you can write down. Am I audible or not? Okay. Now, okay. So write down another question. The circuit is given like this. This is 15 volt, 2 ohm, this is 1 by 3 Faraday, minus plus 7.5 volt. They are asking what is V. Okay. The question is that the find out V of t at t greater than 0. At t greater than 0. So write down all the question here. Write down the question here. Completed. So the meaning of the circuit is that the switch is open for the switch is open for a long time. The switch is open for a long time. At t equal to 0, the circuit is closed. Find out what is the voltage across capacitor at t is greater than 0. The question they asked like this. Okay, so I can write down here. So in exam, we will not get anything. So just the circuit. The switch is open for a long time. Open for a long time. Okay, switch is open for a long time. At t equal to 0, it is switch on. It is switch on. Okay. So I'll take these two cases. Case 1, when t is less than 0. So I'll draw the circuit here. This is plus minus. This is 2 ohm. This is 1 by 3 Faraday. 1 by 3 Faraday. So this is voltage across capacitor VC. This is plus, this is minus. This is 15 volt. Okay. They're saying that the switch is open for a long time. When the switch is open, I will get the circuit like this. So that means this circuit is not connected. This entire circuit is not connected. Only I will get this circuit. This is t less than 0. So the circuit is open for a long time. That means this capacitor achieves steady state. So steady state means capacitor behaves as an open circuit here. So I can remove this capacitor. The capacitor behaves as a open circuit. Capacitor behaves as an open circuit. So I want to find out what is voltage stored at the capacitor at the initial. So I can write down here VC 0 minus VC 0 plus means just before switching and just after switching, the voltage across capacitor is nothing but the voltage here. So this is nothing but I will get 15 volt. This I will get 15 volt. Okay. This is nothing but the initial voltage. Initial voltage. This is the initial voltage I got. So one thing is over. Now I will take the case 2. So case 2, the circuit is closed. So let me draw this diagram. This is plus, this is minus. This is 15 volt. This is 1 by 3 Faraday. This is 2 ohms. This is 6 ohms. This is minus and plus 7.5 volt. Okay. This is T is greater than 0. See here, T is greater than 0. Now, when T is greater than 0, I need to find out what is voltage across capacitor at infinity. Voltage across capacitor at T equal to infinity. That I need to find out. Obviously, when T equal to infinity, the capacitor again behaves as a open circuit. So I take the capacitor behaves as a open circuit. Capacitor behaves as a open circuit here. This is your A. This terminal is B. So I need to find out what is VAB. Okay, so how to find out VAB? You can see here, this is the closed circuit. I can find out the current here. Once I find out the current here, so I can find out what is drop here. Then I can find out what is VAB. Okay. So now I'll apply KVL here. Let I amount of current is flowing. So I'll putting the KVL. So I'll get minus 2 plus 15. Then minus 2 into I. Same current will flow here. This is plus minus 6 into I. Then minus 2 plus this is 7.5 plus 7.5 equal to 0. So you can find out 8I is nothing but 22.5. So what is the I value? Please tell me. What is the I value? 22.5 divided by 8. How much I will get? How much I will get, Ra? Tell me the answer. Unmute your mic and tell me the answer. Or you can write down in chat box 22.5 by 8.
0.8124.
How much? Or you can write down in chat box what is the 22.5 by 8.
2.8125.
2.81 ampere. Let 2.81 ampere is flowing. Okay, so I got 2.81. Okay, now 2.81 is flowing here. There must be a drop here. Voltage across 2 ohm. The voltage across 2 ohm is 2.81 into 2. How much I will get? Tell me. 2.81 into 2. I will get 5.62 voltage. 5.62 volt. Okay. So I'll get drop here equal to 5.62. Okay. I want to find out what is VAB. So I can write down here. This is A. This is B. This is 15 volt. This is 15 volt. Here drop is 5.62. This is plus, this is minus. Okay. So now I can apply KVL here. Minus to plus 15. Plus to minus 5.62. Then this is plus, this is minus. minus VAB equal to 0. So what I'll get, VAB is how much? 15 minus 5.6 to how much? 9.38. So I'll get 9.38 volt. So this VAB nothing but your VC at infinity. VC at infinity is 9.38 volt. So I got the voltage across capacitor at infinity, voltage across capacitor at 0. Here I got voltage across capacitor at 0. Now third one is that I need to find out time constant. So time constant is nothing but RC. So if you want to find out time constant, again you need to redraw the circuit. So I'll redraw the circuit when t equal to infinity. So this is plus minus 15. This is 2. This is 1 by 3. 2 ohms. 6 ohms. This is minus plus 7.5 volt. So across capacitor, always you need to find out the time constant. So let this is your A, this is your B. What is RAB here? So RAB can find out 2 and 6 are parallel. 2 and 6 are parallel. Okay. So RAB is 12 by 8. 12 by 8, C by 2. Okay. So I can find out tau equal to R equivalent into C, that is 3 by 2 into 1 by 3. So I'll get 1 by 2 here. So I got time constant here. Now I got all these values, so I can put here VCT equal to voltage across capacitor at infinity plus voltage across capacitor at initial value, voltage across capacitor and into e to the power minus t by tau. I can write down here. What is the value I got? 9.38. 9.38 plus. So VC0 I got 15 minus 9.38 into e to the power minus t divided by 1 by 2. So what I'll get now? 9.38 plus 5.7 around e to the power minus 2t. This is the voltage across capacitor when t is greater than 0. Okay, this is all about your RC circuit. Similarly, we can find out current through the RL circuit. Just to write down the formula. So in the next class, probably tomorrow, not tomorrow, today evening, I will take another class. So write down, or I will post the video in the YouTube. IT equal to I voltage current through the inductor at infinity plus I of 0 initial value of current I at infinity e to the power minus t by tau, where tau equal to L by R or R by L. What is tau? L by R or R by L?
L by R.
Tau equal to L by R. So regarding some problems of this, I'll solve in. I'll do it and post in YouTube. Okay. So I hope you understand this thing. I'll put this video also. You can check this video if you have any doubt. You can see this video in this particular your MS Teams. Okay. So now, if I have any doubt, you can ask, or I'll end the meeting. Anyone having any doubt? No one. Okay, so this recording also you can